All righty, let's get this started. Looks like no one in yet. Okay. Share screen. Share that. And let's get the chart up. Alrighty, I think we're good there. Okay, so I don't know if 11 views means that's people that have checked in, checked out, or if that means that we have 11 viewers currently. If you could let me know, comment in the chat, that would be super helpful. I'm also going to check over at YouTube because we're doing this simulcasting. Let's mute that. Okay. All right. Alrighty, one more minute till we kick off. Doesn't work for you. Let me send you YouTube stream. Alrighty, it's 11:05. I have no idea how many people are in here because it just says 27 views. So I might be talking to myself right now. I think this records, hopefully. If so, we'll be able to replay. If not, I'm going to be having a very lonely conversation. So first and foremost, I want to kind of talk about recap for a second. Then we'll talk about why we're doing this dev stream. And then we'll get into the more interesting bits. So why recap in general? I think it's important for companies to give, recurring updates. And that's what we've been trying to do every Thursday. We are a smaller team. We have a few people, which means that we have, we target this 2-week release cycle, and we don't always have exciting features to talk about every single Thursday, which makes every other stream kind of boring. So I was trying to figure out a way that we could, get around that. And Ace had a great idea, which is, hey, why don't we do, a dev stream instead? And he thought of this as like a supplemental once a week or, once a month sort of thing. And forget who I think it was actually Fred Harper from the Coop First team who suggested it and said, why don't you just do it? If you do it every couple of weeks, that's good. And I thought, oh, what if we just replaced, half of the like product updates with tech updates? And we can kind of target two different audiences here. First is, anyone who has a reasonable technical understanding, wants to understand more of what Caps One, how it runs under the hood. That's obviously valuable for people who are bought into the ecosystem that we're building. But on the flip side, if you are a brand new dev, and you're like, where do I get started? I'm going to walk you through some of the key decisions. So this is going to be a little jumpy compared to if you go on YouTube, million tutorials on here's how you start a Next.js Vue Svelte app. Here's how you integrate it with an OpenAI API or whatever, right? Bunch of options there. We're not going to recreate that. If we were to do something like a paid tutorial at some point, down the line, it would really, there'd have to be like a swell of support and people really interested, because it would be like 100 hours to build something like that, right? Whereas this, I can hop in, and if you guys have any questions, please, let me know. I'm going to do my best. I'm not a good streamer. Obviously, I'm not good in front of camera, but I'm going to do my best to try to balance. So if you're talking in the YouTube or the Twitter stream, I'm going to try to bounce my eyes around so I can make sure I'm not totally missing anyone. But yeah, so that's the recap and the dev stream. The other reason, obviously, and this is just more practical, we have to market Caps One. I just like to be upfront about that. Obviously, we want Caps One to be more prevalent. We built a lot of features. We're getting ready to monetize the app. Core features that we have always be free, but we're launching some paid features, and we need to start really doubling down, getting our name out there. And I thought, like, man, this is probably the best way. Is like, I would rather listen to someone tell me, some part of it that they're really passionate about, instead of just sell me a product every week. So hopefully you guys find this interesting. Very open to feedback. If this is too high level, too low level, please let me know. I will try to basically cater this to whoever is the most active, so if we get the same couple guys that show up every week and you guys have a specific request, that's what we're going to do. So with all that said, I want to give you guys a brief intro about who I am. So I've been in software. I'm actually a self-taught developer. I got started when I was 12. And from there, I've just been chipping away at this year after year in a variety of capacities. So I've been able to work in, front end, back end, design, architecture, DevOps, product management, program management, IP management, legal stuff. So I've really gotten to explore a variety of different, venues, and worked across, multiple industries. So I think I have a pretty solid perspective in the sense of like, what does software look like in the real world, which I think is, maybe different than if you learn to build an app, but you don't actually like translate that to, real, real users, right? Two of the companies that I was early at went on to be unicorns. So, that was kind of what, third time's a charm, right? So this time I wanted to take a crack at it, and here we are. So I'm going to give you really a look at like how I think about this as CEO of Caps One, all the way to how do I think of this as like the solo indie dev at Caps One back in, when I started in 2019, right? And since then we've been able to hire and grow, which I'm grateful for. But really, I want to make sure you guys get the broadest possible perspective. So this is the thing that I think about most nowadays, right? I think about, token and or fundraise, and what is the market like, and what are meme coins doing, and how is everyone else? It's like that's what we all think about every day, is like money flowing into the market, right? So we're going to work towards this, right? But before we jump to this point, I want to kind of take you to what's maybe more relatable, which is your computer. So you have a computer where you write some code, and you want to be able to run that somewhere, right? So you write some code and you go, I'm going to publish that to a cloud. Now you might have heard of Amazon, Google, DigitalOcean, Azure, and all you need to know, if you don't have any familiarity, is that basically there are servers that other people will sell you pieces of, or entire servers. Generally, it's a piece or a virtualized aspect of that server. And what that allows you to do is say, like, I want to take my code and run it somewhere else for cheap. So I'll show you a couple practical examples. Vercel is probably the most common. So let me go pop open in a new one. So you could, for example, come over to Vercel or a site like netlify.com, or let's say Surge, or you could do Cloudflare. All of these companies, I mean, they have different specialties, but their broad appeal for most people is I can use their command line interface, their terminal window, to say, I want to deploy an app somewhere outside of my computer so other people can access it, right? That's, I mean, the broad appeal. And so this kind of ease of access, we generally call a backend as a service. And all that means is that you have a cloud provider that has abstracted away a lot of the low-level detail. So if I am, for example, using Amazon, I might use something called an EC2 instance. And this Elastic Compute instance is basically just a virtualized server that I have access to, right? So I could, for example, let me go over to, EC2 pricing just as an, get a little more detailed. So I could come around here and try to figure out, what do I need? What size box do I need, right? But this is all fixed. So one of the problems you run into right away if you don't understand what you're doing is, well, how do I know how big the server should be? How do I know where the server should be in the world? And how do I, make sure that traffic gets routed there appropriately, right? So in other words, like if someone is in the UK, and they're trying to access something that's hosted in San Francisco, for example, that's a huge problem because they're going to have noticeable latency, right? And one thing I told you guys in the tweet is that we are targeting this for finance apps, obviously. So what this means is that there are additional considerations for building a scalable finance app that are important to consider, right? And so we will come back to that at the end when we, it depends how long this thing goes. I'm targeting an hour for this, so we'll see how far we get in the roadmap. We might have to break this up into a couple calls depending. And then we will dive deeper into, what does scale actually look like? What does low latency look like, et cetera. So let's go ahead and close out of all these. Actually, let's go ahead and close out all these. That's fine. And now that we've talked a little bit about cloud providers and hosts, or these servers where I can host things on, we now immediately come to, let's skip this for a second, and let's go into source code management, right? So part of the reason we're skipping these is that this is a vital part of the process. But when you're first getting started, you pretty much don't think about this, right? You think, I have some place to store my code. Generally, it's GitHub. It doesn't have to be, but that's, the option people choose. You could technically host it in a Dropbox folder if you want, or box. Whatever, right? You have options. But generally nowadays, people lean in the direction of Git. If you don't know, Git was actually made by the same guy who made Linux, Linus Torvald. So pretty cool. That's part of the reason it's ubiquitous software. And all GitHub does is it allows you to basically track different versions of software. So for example, if I were to think of a version, this is an oversimplification, but just in case you have never heard of Git, and I were to, let's say, publish a series of updates. Now, if someone else came along, let's say that, this initial is the alloc branch. You could think of this analogous to like, chain if you wanted to. And we'll call this the blob branch, right? So I come in here, I write the V1, that gets published to V2, and then blob comes in and forks that, right? So now he has his own V2. Now, generally, it's not actually called a V2. You get a commit hash, which looks like random gobbledygook. If we were to look, for example, at AdPort, which is a admin portal, you'll notice that there is this, it's probably too small on the screen. Actually, let me look at commit history. You'll notice there is this commit detail. So you get this, 7-character digit, which is actually much longer. And that then is basically what identifies this. Kind of like if you have a user account in a social media profile, you have a UUID. This is very similar to that, except it's a unique way of identifying individual commits, where the commit is kind of like the version, so to speak, that you've pushed. If you actually understand Git, you know that I'm cutting a lot of corners in that explanation, but I also don't think, if you don't know Git, it's not really worth me trying to explain all of it over this video. Fantastic 10 to 15 walkthroughs that will teach you in depth in a very visual way. So definitely check those out on YouTube if you want a deeper explanation, or feel free to ask and I can, sidebar from there. So let's say then, we had another person. You can imagine that this can continue to fork. And then eventually we go, all right, we have a merge target in mind. And so we want to push this to our master branch, right? So we go through now a merge process. And this merge process is basically the last step. So we say, all right, we're going to merge all the things. And it, even if you don't understand the concept of merging, what's happening under the hood, what it's really doing here is taking two pieces of text, diffing the differences. That's redundant. And if you add, let's say, for oversimplification of visual, if you add some text at the top of the file and I add some text at the bottom of the file and there's no collisions, both of our changes can be merged together into one file. And now the overall file changes, the text changes itself, but we don't have to worry about anything else. So there are some other examples where merging can break. If, let's say, Alec and Blob both try to change the same line of code in the same location, that'll break, right? So when all that's said and done, the merge is successful. Now it gets pushed to master. Now this is ready to deploy. Now, if you've never deployed an app and you follow a tutorial, they will tell you to use something like Vercel or Netlify, which we talked about. And what they'll say at this point is then integrate this with their profile or their config. And Vercel will, or Netlify or any of these, will provide you some type of config where they'll say, all right, give us the name of your master branch, or, so you can name it master, main, foobar, your first name. You can name your root branch, whatever you want, right? And then they will then look for that to say, there's been a change here. Go ahead and now run a script. And all this script does is then push it to Vercel's servers, right? So now Vercel has some servers that they deploy to, and that script runs. And now you can, this host, or the files there are then hosted on Vercel. And then Vercel does some other things like link your domain to those files, and now you can access it remotely, right? We're not going to talk about TLS or anything on this call because we're trying to get through this entire flowchart. But again, if you guys have any detailed questions, happy to dive into it. Now, going back to this process, we just talked about SCM or source code management. Sometimes you'll hear it called source control management, depending who you ask. But the source code management piece is important. And what we just described with this Vercel script over here is exactly the CI/CD step, right? So the SCM, in this case, GitHub or GitLab or Git, wherever we're hosting our thing, will then integrate with a deployment script. And that deployment script can do more than just push code. It could, for example, you could update a Discord server that you have a new version available, right? Pretty much sky's the limit. Whatever you think you could do with code in a general sense, you can also do in these scripts. And that then deploys that to your target. So now we get to this infrastructure, right? We already talked about clouds. We talked about what it looks like to have a VM or a VPS, a virtual private server, or a virtual machine running on, an existing server, et cetera, et cetera. But this is where it gets interesting. So normally when you get started, you're going to do exactly what I did in the beginning. You're going to go to a site like Vercel. I'm not a fan of Vercel, but I use them because they're so ubiquitous, or I reference them because they're ubiquitous. And you'll click around and they'll show you how to deploy this thing. We call that ClickOps, meaning that you have to configure things by clicking around the dashboard. Now, Vercel is actually not bad for that because it's, again, it's this backend as a service, basically, where it handles, or platform as a service, depending on who you ask. And it basically handles that implementation detail for you, right? So that's all fine and dandy. The problem comes into, or the problem enters where you have more complicated systems, right? So what happens when now I just have a single server and a single website to manage with a single domain, but I have a confluence of apps and services that I'm deploying? So for example, if I were to look at, let's go to GitHub/CapSwan, and look at the number of repos that we have, you can see that we have 114 repos. And there's a bunch of, libraries, dependencies, boilerplate, standalone services, apps, all bundled into that. But we have about, give or take, 30 services that run in production currently, right? And you can imagine, especially at larger companies, that scales up to hundreds or thousands of services, right? And so now, good luck managing that with ClickOps, right? So one of the first things that you'll then do is you'll say, I'm going to script this. Now, scripting is great. If I wanted to do, for example, using the Vercel example, Vercel deploy right from my terminal, from my local computer. I don't even need to integrate with GitHub, right? I can just push code, which is great. And so there is some advantage to the simplicity there. And I could write, for instance, I could write a little wrapper script that is something like, if I go, I don't know what's in there, so I'm just going to make this a demo. And we will do touch example.shell. And now I could do something like, let me zoom in because I know this is super small. Now I could do something like Vercel deploy and echo deployment complete. This is very, very simple, but you get the point. And I could run this script then, and it would automate. Let's imagine that I had, an app that I was deploying here. You could then get all of this automatically. So I don't have to remember how do I do the deploy command? I don't have to then remember, okay, how do I print something to the terminal, or what do I say? It's all automated for me. So that's pretty obvious why people do that. And they do a lot of that, right? So for example, if we were to look at, let's go to LunarVim, which is actually the NeoVim editor that I just used. If we go to, let's say, the install script, and we look at, where is this? Installation. And let's do here. Come on. So we look at this install script. Imagine you had to do some combination of this every time. That would be a nightmare, right? There's a ton of edge cases. I don't want to do that. I want the script to handle it for me. The problem, though, with relying on a system like this is that this is what you refer to as procedural code, right? Meaning I do a sequence of steps and I make sure that everything runs in a certain order. And that on the surface sounds great, right? The advantage of this is I automate that previously tedious task we talked about of I have to click around, or I have to, try to remember what commands to type in the terminal every time. It's nice that I have a script that I can run over and over again. A lot of DevOps people stop here and they never move forward, right? And for, it's worked for decades, right? So that's not a knock against them. If it ain't broke, don't fix it, right? So, there's definitely a case for that. However, I am a big fan of something called GitOps. What GitOps does is it describes a SCM sync. So you write code that describes your infrastructure, and then that's reflected in the code that you deploy. So for example, if I look at our GitOps repo, now this is actually running kubefirst, which if you are going to ever think about using Kubernetes, which we'll explain a little bit through this process, I would strongly recommend checking them out. If you are an absolute beginner, don't worry about this step. Glean the high-level principles of GitOps. Don't worry about the implementation detail. So if I look at this repository for GitOps, one thing that you'll notice is there's this file called Terraform. So if we were to look, for example, at this file, we have a main.tf. And if I were to go to, let's say, the Terraform IO, what you'll notice is it talks about this infrastructure as code, or IAC. And what this basically says is in a declarative system, I want to know that I can describe the state of something without having to, reverse engineer the exact steps. So for example, with, if you're thinking about this in traditional programming terms, I want to, calculate something, what's, 2 + 2. So I write a function that is, function add, I take in 2 integers and I output an integer and I test it and I say 2 + 2 = 4, right? With machine learning, when I'm writing a neural net, you do the opposite. You basically give it an intended result, so to speak. And then you say, all right, pass all of these data, these pieces of data through and see how close we can get it to the desired result, and expect this neural net to describe the steps in between. So if you think about it, this is like a really high level. If you've never thought about like the magic of AI, if you just see Sam Altman get on board and you're like, how does this genius do it? the core process is very simple, which is that if I take let's say a function and I produce an output from that function, right? I am describing the exact steps, and then I have some data that comes in. And this data then goes into the function and then defines that output. Now, this is obviously very oversimplified, but you get the general idea, right? So now let's say that I change this a little and I say, all right, well, I have up front, I have the data and I know what I expect the output to be, but I don't know what the function is yet, right? This is what we're talking about. So I want it to basically define the function or the series of steps that it takes to produce this outcome. So very, very high level, but hopefully it gives you some sense of the why this, how declarative can look outside of just infrastructure, right? So if I go to ChatGPT and ask it to give me X, Y, and Z, I am just describing inputs, right? And it is then saying, all right, based on my model, I'm going to run a calculation and then determine that it should look like this should be the text output, or this should be the image output, or whatever, right? But all in all, it's basically just a rework of existing comp sci principles that we've had for decades. Now, it's very impressive, and I'm not trying to minimize it, but I at least like to give some indication of what's happening under the hood, so it's not just like this, mysterious black box. So, getting back to this idea of declarative code, when I run, let me pull up here. When I run, for example, and I'm not going to scroll any further because I don't mind if you guys see the endpoint here, because we're going to be hosting this, but I also don't want to give too much and I don't remember everything that's output. But I'm here describing an S3 bucket, right? So the S3 bucket would refer to, for example, if I go to Civo S3, you'll see this object store, right? And the object store is basically a different version of Amazon S3. So if you've ever heard someone say S3, all you have to think about is cheap storage online. That's it. And S3 was so popular, became a standard because Amazon was obviously ubiquitous back in the day. They used to give a ton of startup credits. They still do to some degree, but you have to know someone or be part of a special incubator program. It's not like it used to be. Back in the day, you could like sneeze and they'd hand you $100 grand in credits, basically. And so this S3 storage is interesting because it has become a ubiquitous standard. So if you go to any other cloud, you expect to find something that's S3 compatible. So you can then use software like, for example, Minio, which is a K8s or Kubernetes native solution where you can actually host data that is S3 compatible. And this core idea, and you're like, well, you just jumped through 4 different tech stacks. I don't know what's happening. The main thing I want you to take away from what I just said is when you are building software at scale, it's really, really important that you don't lock yourself in too much, right? If you find a really opinionated system, super easy to get started with. If you find, however, that you need to make changes, it's more rigid over time, right? And so that rigidity has a initial pro and a long-term con. And that con can exist in a couple ways. Like, for example, like a decade ago, I worked at this company and they, basically 80x'd their cloud costs in the first year. And this is not an isolated incident. You talk to anyone who's managed cloud at scale, it's very, very expensive. That's why you hear guys like DHH on Twitter. If you don't know, he's the 37 Signals Basecamp founder. It's a project management software. Basecamp.io or Basecamp.com. I don't actually use it. But yeah. So anyways, founder of this software. And he talks quite a bit about this idea of like, moving away from the cloud, right? And so they wrote software to enable that. And the value here, and this is going back to infrastructure as code. If I write code and then I write infrastructure code, now I'm not locked into AWS or DigitalOcean or GCP or whatever. So now think of this in terms, I'm assuming crypto people are watching this because obviously, we're on CT and I know that I have a few non-CTs that I'm mutuals with, but I know that's a minority case. So if you think about it in terms of chains, there's obviously different reasons to use different chains. And if you're looking to optimize for cost, you would look for something else, right? So there are like super cheap clouds like Hetzner, for example, which may not offer the same uptime SLA as, let's say, AWS. If you don't know what SLA is, just as an example, A service level agreement is typically what a cloud provider will say they can guarantee, right? So like what you'll hear, the shorthand, if you've never heard anyone say this before, is like AWS will say, we have a 4 nines SLA, right? That's kind of the shorthand, how you'll hear it said. And then you can actually see the level of uptime or downtime you can expect. So like yearly, I can expect 4 hours of downtime at a 99.99% SLA, right? Whereas if, let's say, something offers something like a 99.5, so this would be 2 nines, you can see that's almost 2 full days of potential expected downtime. Now, that doesn't actually mean the cloud is going to be down for 2 days. It just means that they have a service level agreement with you where they're saying we aren't going to go past this magic line. So when you're looking for a cloud, besides how expensive is it, what kind of features does it offer, et cetera, you're trying to consider, what does my uptime look like? And uptime.is, super easy calculator, recommended if you've never used it before. So let's go back to our demo here. So we have now this KubeFirst example, and we've talked a little bit about Terraform, which kind of sets us up for that. So what's KubeFirst? What's Terraform? Terraform is the thing that says, here's the servers and domain names and anything else that I want to configure remotely. I have a system where I can say, make it look like this. And then afterwards, I can actually do that, right? And so it handles that automated intermediary step for me, which is great. Now, on the flip side, if we're looking at something like Kubernetes, which is a cluster virtualization software. So like the way you can think about this, because I realize I just said random words if you've never heard them before. So back in the day, let's say that I had a computer. So we're going to explain what is virtualization, why is it important, and then we'll get to clustering and that sort of thing. So back in the day, I would have a server, and that server would say like, okay, I can now host my app on top of this server. And assuming that my requirements for this server are paired nicely for this app, no problem. But at some point you scale, and usually clouds are pretty good about giving you the ability to scale this server. We call this vertical scaling. And so I make the server as big as I can make it. And at some point I go, you know what? This is getting really, really expensive. I need a second server. So I need a server and this isn't scaling enough. And how do I handle this? Well, it may seem obvious in the sense that you can just have 2 apps now running, but there's no actual shared resources, right, between these two. So it may just seem like, oh, well, now I've, taken this load and distributed it, but you actually haven't distributed anything. It's a counterintuitive problem. So let's say that, for example, this server has something like 50 or let's say 60% usage, and you're like, okay, that's decent. I want to leave some margin in. And let's say the second server that I added is something like 20%. You now have all of this, dedicated compute that you're paying for, which is problematic, right? Because now you're paying for 2 expensive servers. And it might be cheaper instead if you had something like, let's say, smaller servers, right? So this is where you start to deal with levels of granularity. But now imagine that you have to deploy apps for each one of these. You can now see that it's a breadth versus depth problem, and the complexity in managing this escalates. So some really, really smart people. I don't remember the first company to do it. Negative nerd points for me for forgetting that. I want to say VMware, but I don't actually know if that's true. But right around 2009, there was a significant shift. And this is when you started hearing about AWS and the cloud. And really the thing that allowed this to happen, besides people having demand for it, was that they wanted to introduce this concept of virtualization. So now I can have a single application. Let's grab one of these bad boys. And that application will then access all of the resources inside this, we'll call it a pool, although maybe that's not quite right, a pool of servers, right? And so now the load actually gets distributed across these. And the general idea is if you have good virtualization software, it should distribute them fairly evenly. So now if we had something like, and it's never a one-to-one, but just for, if we said this was like, hey, 60%, and this one's 60%, and this one's 40%, and And you're like, okay, everything looks pretty good here, right? It's much better than the situation we were in before where we were paying for really, really expensive servers. And if you've never deployed an app and you're like, what does expensive mean? Like you can pay thousands of dollars a month for individual servers. Shout out to all the SQLana manlets that are, paying for very expensive hosts. I think that's the common running joke for expensive servers in CT, but like it is a real problem, right? So this virtualization solved an issue. So now you think, all right, we have apps and servers. We have virtualization that allows us to bundle all of those servers. Then we have fancy script, basically, that we're calling infrastructure as code that allows us to deploy two specific servers, right? Two specific clouds, and then they implement some code. And then we have a CI/CD script that then takes that code that we just recently deployed this infrastructure. This now takes that code and deploys it to this newly provisioned infrastructure, right? So we're starting to see how this comes together, and you're like, okay, so now we have some code. We have code that the user runs. We have code that our system runs. We have code, so like front-end code, back-end code. Now we have some deployment code, so we can call that middleware or whatever you want to call it. I just say CI/CD scripts for simplicity. And then we have source code to manage the things that the code itself is running on, right? So this is what you like. At this point, you're probably starting to see the problem with a system like this. It's pretty complex, right? And so it gives us a ton of control, a lot of granularity. And if you have a large team, it's fantastic. Now, back in the day, I got started with Kubernetes back in, I think, 2018, either beginning of 2019 or end of 2018. I think 2018. It was very different back then. Not much tooling, basically surrounded by gigabrain DevOps people who know much, much more than me. And me trying to glean some insight into, okay, how do I make this basic app run in this complicated system? That's how Kubernetes used to be. And thanks to KubeFirst specifically, you've probably seen me tweet about them in the past. They have done a phenomenal job. They've done a phenomenal job at creating basically a turnkey solution for GitOps. What this means is that you can basically run a script and they will handle deploying everything for you. So when it comes to Terraform files for all of your servers, whether you want to work with Amazon or Google or DigitalOcean or whatever, you have all those options, right? And then they give you an easy way that you can actually then deploy apps. So if I look, for example, let's go into environments here, you can see we have staging, production, and development. And if I click into staging, let me just click on add port, you can see all we're passing it are these config files. Give me 1 second. Hang on. Sorry about that. Yeah, thank you. No, that's okay. Thank you. These config files basically are what define the state of the application, so to speak. So if I click into chart, for example, you can see that we have some very basic description. This is called the YAML. It's just a config file. This is called a key value pair, if you've never heard of that before. So the parser for this YAML file, which is the Kubernetes that it's running on, recognizes some things like API version means something. This isn't something we deployed or coded. This is something Kubernetes understands. It understands what dependencies mean. It understands description and name and type, etc. And so what we can do then is pass in information about the state of our application, and then we can automatically deploy that to an end target. Now, if we were doing that manually, it would be very tedious. What KubeFirst does is gives us the ability to automate that entire process. And free and open source, they were recently acquired by Civo, which is a Kubernetes native cloud provider. So shout out to both of them. I've worked with both of their teams. Really, really responsive, phenomenal customer support. That's not something you get at Amazon or Google. I've tried all of them. I would say if you were looking for an easy way to get started, not in terms of cost optimization for that, that's a different question because there's some really, really cheap Vultr or Hetzner type options. But Civo is one of the cheapest Kubernetes options. If you're looking for a general purpose cloud to get started with that isn't just Vercel or Netlify, I recommend DigitalOcean. I think they're really developer friendly. They are a little expensive, if you're running Kate's clusters on here. So that's, compared to Civo, but experience with them has been great. Super responsive team, recommend. And they have a more traditional cloud that's not just Kubernetes native. So if you're looking for their equivalent of Amazon EC2 instances, or these virtualized servers are called droplets. So you can basically build a very standard application with them, and you can get started. So I'll stop shilling clouds that I use. So going back to this, now we've said, all right, so with GitOps, we can basically update code, and then a series of scripts will then look at those code updates and go, all right, I'm going to automatically deploy that to a server. And then you go, wait, isn't that the same thing that we just talked about with CI/CD? Like, didn't we just say that this is how you deploy code? Sort of. The main difference here is that the code that's being updated is describing the state of the servers that you're deploying on, or the host, however you want to say that. Host is, probably more accurate because you're factoring virtualization anyways. And then secondly, you're talking about updating the state of the application. So the cluster itself has additional state. I'm going to open this on a secondary screen real quick. Give me 1 second before I show this, because I think we are good. So I want to make sure I'm not like leaking anything super sensitive. Give me 1 second, sorry. And Argo CD. Nope. I want development. Perfect. Okay, here we go. So if I'm looking at this, and I'm not going to click into these because I don't know what log leak is going to look like. But you can see, for example, development environment, BPL, service bun, Elijah. This is a boilerplate that we have deployed on our existing cluster using something called Elijah, which is a replacement for Express.js. What did I just say? If you have a code like I want to query a backend. So if I went to, for example, twitter.com/caps1app, what actually happens when I do this? Well, Twitter is listening on a root URI or endpoint, and it says, I got some data here. What do I do with that? And so it's going to take the data that's passed here, and it's going to immediately start looking up a name, right? So when you look at that, you're thinking, all right, well, how does that get processed? So generally what you'll do, and this depends entirely on language, stack, et cetera. So we can dive super deep on that in a future call. If we did that, it would be, hours and hours. But high level, you're trying to figure out, how do I deploy a front end? So I could use something like, if I looked at, React for a front end, that's what we use. There's a bunch of others. I have friends that like Vue and Svelte. Solid.js is less popular, but I think it's probably the best on the market right now. We just haven't switched to it because of, interoperability. Quick is another one that was made by ex-Angular developer, which is great. Recommend checking them out. We actually put together a little boilerplate for them. Harder for us to port our existing code over, so we didn't do it, but really interesting technology. Now, this front-end user or UI or user interface, this front end with React is great for getting started, but it doesn't actually describe a backend. Now, when you have a framework, like you've probably heard of Next.js before, and you'll notice, Vercel, we've come full circle. Vercel made an open source framework called Next.js. And so what's cool about this is like you can then get started knowing you have the backing of like a company that's doing well supporting this framework. Now, every framework you talk about, especially in the JavaScript ecosystem, is always going to have controversy around it. What I will say, you refer to this as bike shedding typically. Like when I was 16, I coded in PHP. I make fun of PHP now. There's nothing inherently wrong with PHP. It's just fun to mock it, right? But if you don't know that, and some people genuinely are tribal and they genuinely hate PHP, and that's fine. But if you don't know that game and you're looking into this, you're sort of like, well, why does person A like this thing and person B like this thing? Don't look at popularity as an indicator of best technology ever. Generally, people are looking for a few different things. Let's kind of zoom out for a second, talk about developer experience, because I think that this is actually good context to have in general. If you are a developer, you're thinking about your developer experience. And this can mean a number of things. For example, I have a split keyboard, and that makes my typing, my wrist more ergonomic, right? So like, in other words, like I don't have to worry as much as I used to about carpal tunnel, right? The other consideration you have is speed. Now this can mean a number of things: network latency, code performance, etc. But broadly speaking, we'll just say speed. And then what is this? Familiarity. So does this make sense to you? Can you easily grok it, right? There's a lot of good technology that I ignore simply because I don't want to take the time to relearn, etc. It's too much overhead, right? Familiarity is obviously important, but it shouldn't be a hard blocker. There's a lot of great technology. When I first heard of Kubernetes, I thought it sounded dumb. And eventually I was like, wait, this is great. I love it. And if you've followed my tweets, you know I show it pretty often, specifically Kube first, but this core idea of I don't have to worry about this orchestration detail. And it's like, that's great, right? Familiarity. So scale. Scale is important. I want to know that I can get code up and running. And when it is, I want to know that I can trust that it will scale up effectively. This is actually, from a capstone perspective, I'm doing this really high level and jumping around, you know, pure ADD style, but we can dive into some more specific capstone examples in future streams. But this concept of scale is really important. It's actually something that we struggle with now, right? Because we built our production cluster that we have live as it stands in a more rigid way. Going back to this, we started, when I started my dev journey, you know, years ago, it was in a notepad.txt, writing an HTML file. But eventually I worked my way into ClickOps and learned how to use, you know, some various clouds. But when I got into ScriptOps, I kind of fell into that hole for a while, right? And so one of the problems is, like, when I first started CapSwan and I was like, oh, this Kubernetes thing is great, I fell into the trap of ScriptOps. So I was manually installing things, which means that if the cluster goes down, it doesn't automatically just boot back up and everything works from day one, right? So there's a lot of config, and for existing production code, that's not great. So that's why you'll notice that we talked about this. We have this, you know, obviously this GitOps repo. This is the state of our new cluster, which we're going to be migrating everything to in the future. And this opens up a lot of advantages, which I won't bore you with, but we'll talk about in a future stream. So going back to here, our scale. This scale thing is important, and part of that scale is figuring out cost. So, for example, services like Vercel are great up front because they say, hey, well, you know, definitely for you, no problem. And then they go, well, just so you know, it's 40% more expensive than Amazon. And you're like, that's a steal, because I don't have to develop any of the infra, like, I don't know, a Terraform and a Kubernetes, a kubesecond. I don't know what any of these things are, right? You're like, I don't want to deal with that. So I go to Vercel. The problem is that if you get hit with like a DDoS attack, they're supposed to have some degree of DDoS mitigation, and, you know, you use a CDN to configure or to wrap your domain so that mitigates and stuff. But at the end of the day, you see a number of horror stories where people are like, I did this thing and it ended up costing me, instead of hundreds of dollars, it cost me thousands of dollars, right? Some of them, I saw a horror show the other, what was it? Probably, I don't know, it's probably 5 years ago now. This Firebase incident that's pretty notorious online, where this guy had a program that ended up spinning up $30,000 in cost over a 3-day period. Now that's an exception. You shouldn't assume that's going to happen to you. We use Vercel for a couple, like, you know, one and done, very low priority, insignificant sort of like workloads that we have. And so it's not the end of the world to use solutions like that. You know, use the tools that are at that you have available to you. However, be mindful of that cost, because a lot of times when you look at the cost, the simplicity of going, just like, I keep picking on Vercel, so let's pick on Netlify for a second. You look and you're like, wow, $0 to get started. That's fantastic. And it is. Like, I'm not knocking that at all. But then you start to look and you go, oh, this pro plan, $19 per member. Interesting. So if you have a team of 3 people, now you're spending $60 a month just to be able to deploy code like you were already doing. And that's not including, let's say you go over a terabyte of bandwidth or anything else. So now you start to get into this nickel and dime problem. Again, $60, not the end of the world. You can pay that, right? But you start to figure out, okay, what does my cost look like? So there are some other interesting solutions that address this. I think Coolify.io, really, really cool. This is a self-hosting ecosystem that I recommend checking out. We don't personally use it. I followed the dev who founded it, and He seems like a solid dude. I've briefly looked at the tech stack. Seems really interesting to me. We might consider doing it for a small scale project at Caps One, but I would recommend checking them out. They also have a cloud hosting option priced very fairly, so you have that availability as well. But going back to this cost problem, scale and cost are interlinked, right? So using this example of that 80x increase in cloud cost, the revenue increase during that time was 10x, right? The revenue in terms of total cash generated still dramatically outweighed the increase in cost, right? Just in terms of notional value. But 80x to 10x is not a great ratio, right? Why is it an 8-to-1 in terms of scale to cost efficiency? That doesn't make sense. But that's the state of cloud, right? You're paying for that convenience. I don't actually know, you'll take this, what I'm about to say, with a grain of salt. I saw a stat a while ago that was, that said your average bar drink, I don't drink, but if you go out and you order, whiskey on the rocks or whatever you drink, there's something like an 18-to-1 markup on average at bars. Now, again, don't quote me on that. I could be totally wrong about that stat, but directionally that's accurate. If you've ever paid for a $13 martini, you probably know what I'm talking about. On the flip side, the cloud cost, increase is similar. Now, I've seen 18-to-1, 20-to-1, 10-to-1, 2-to-1. I've seen a bunch of different figures thrown, and it largely depends on what you're paying. I mean, there's too much nuance there to give, an exact. But what I will say is, like, it's worth considering that up front. Not so much that analysis paralysis prevents you from deploying everything, but if you are trying to build a real world application and not just a fun side project, which fun side projects are great. You should definitely build them if you've never built anything before. Build something that makes your life easier. Learn from that. Don't let technical gobbledygook stop you from building. I learned when I was 12. I printed out about.com tutorials and took them to school, and I looked like a nerd. I still am a nerd, but I really looked like a nerd back then. And there's no issue with that. Embrace it, right? However, if you were trying to build something at scale, and we know that this DevStream series is going to be targeted towards fintech apps specifically, these costs are really, really worth considering. The scale is really, really worth considering. The speed and familiarity is worth considering. In other words, how quickly can autonomous developers deploy something, right? So we have a team that's distributed. No one sitting, I'm sitting in my office at my house. No one is sitting next to each other. So the problem is, if you are then trying to coordinate these things, I need to know that the state of code that I'm deploying is consistent and reliable. And what I expect to see on, my invoice every month is consistent and reliable. And just to give you real world numbers, because I know everyone loves hearing numbers thrown around, we pay about, it varies month to month, anywhere from about, I think we recently added like another $500. So like, let's say $1,500 to like $1,700 a month, somewhere in that range. That we're migrating to, we were looking at something like, I think it was like 1,000 to 1,500, depending on them. So that cost consideration is not trivial, right? Now, going back to this platform, it may sound like, if you're maybe in this at all, but one thing you should be thinking about is, I described kind of a rigid state when I first built CapSwan, the foundation of it years ago, and it's been, it's taken us far, right? So I'm grateful for that's gotten us this far. But when I talk about, okay, now we're going to migrate to a new cluster, if we have to do that over and over again manually, like, that's just as bad. So part of the reason that I shill KubeFirst so heavily, again, this assumes that you understand, virtualizations and container runtime interfaces and, orchestration software like Kubernetes, et cetera. But the reason I push it so hard is because it allows us, specifically the company, to say, hey, we can then deploy to Civo in the West Coast and DigitalOcean in the East Coast and AWS in the UK, wherever we want. We can deploy in multiple regions, et cetera. But the value for us is that we have multiple workload clusters that make that entire process easier, right? So I would strongly recommend checking out. Again, they're just, have a phenomenal support team. And I'll see you. I pop in the Slack still. So if you ask questions or tag me on Twitter, I'll do the best I can to help. They're much, much more knowledgeable than I am, but I will happy to help where I can. So summary of the things that you're considering: developer experience, speed, familiarity, scale, cost. all these things are important. There are, we could do this list, probably another 30 items, but one last thing that I think you should be thinking about through this process is reproducibility. In other words, if I create code on my machine and it doesn't run on another machine, that's a problem, right? If I write code, echo hello, and it says it runs on mine but fails on yours because yours doesn't support the echo command. Your computer does, and my computer does because it's ubiquitous. But imagine that it didn't. And I'm like, why is this program breaking? Well, because your computer doesn't support that, right? And the high level of this, everyone understands Mac is different than Windows, is different than Linux, right? And so that reproducibility is important. And that's where things like Docker allow us to abstract that. Now, that's one type. When you hear about reproducibility, people will say things like, oh, well, if you containerize your application, that basically means create kind of this thin shim of we'll call it a mini server. We put our code in that little box. Now that little box can run anywhere. It can run on servers. It can run on your laptop. It can run on your grandma's Windows machine. It doesn't matter, right? Because Docker itself is this lower level. If you were thinking about this in crypto terms, it'd sort of be like if you had an EVM, right? You have this virtual machine that basically translates to the opcode that actually executes. So what's important here is like when you are talking about reproducibility, you might get stuck in this rabbit hole of thinking just in terms of like making sure code can run places. That is totally true, relevant to what we're talking about. However, the other thing that's really important is when you're trying to figure out how do I follow the rabbit trail back to where I was? That's when you start to look into things like observability so that you can actually track, what happens when someone logs into my system and what happens when they, for CapSwan, create a prediction, right? I want to be able to trace all that, and I want to see how long it takes in between. And that reproducibility can exist in a variety of capacities. It can also exist from a testing perspective, right? If you are, for example, one thing you've probably seen me show if you're a mutual, is this use Bruno. This is a great open source free testing library basically it's a curl wrapper. So you can test endpoints in your apps. So remember I gave us the Twitter example of twitter.com/capsone app, right? So this, slash is serving as the root endpoint. And when I pass in this value, it's looking for a Twitter handle, and that then, sends back some information, right? Now, if I look at this, Bruno allows me to pass in a, rest verb. Anyways, I'm brain fart right now. But anyways, post, get, patch, delete. You guys know what I'm trying to say, hopefully. You can basically query an endpoint, and then you can test the result in here. So the value of this is like, I don't want to have to go to my browser every time to test things over and over again. I want to know that I can, test it here. But your thought there might be like, who cares? Like, I have no problem opening my browser. Two problems there. One, when you're testing something, you have to do it dozens, if not hundreds, sometimes thousands of times manually, hopefully not, but sometimes it happens. And so in that process, when you are testing this over and over again, you don't want to have to recreate the state of the test, right? Like I don't want to have to pass in users $page equals 2. Now, if I was doing this and it was one, command, and I could just say, paste that into my bar, no problem, right? I'm sitting pretty. But the problem is that that's not how real world testing works. It's much more, there's just a bunch of different variables to consider. And so something like this allows you to automate that entire process. And what's really cool about Bruno, and this is the thing that actually made me, really excited about them, is that they have a DSL or domain specific language. I don't know which of their repos it's in, but basically here, this is a good example. So this, whenever you see a custom language, you can call this a domain specific language. Sometimes you'll hear like YAML, for example. You'll hear like this is a config language or whatever. Generally, if you hear someone say something is a coding language, what that means typically is it's Turing complete, and all that says is, hey, I can use this to do whatever I want. As long as it resides within the P versus NP, space of what we can calculate. I know that this is reliable. Now the DSL will say like, hey, I want to make my own, like we are.